Hi, welcome to solveandgo.com. This video is another video in a series of videos solving questions from the Math 135 final exam from 2010. This one's question number 14, and it's an optimization question. Let me show you the question. So, if the sum of two positive numbers is 8, then the smallest possible value of the sum of their squares must be what? Okay, so smallest possible value, we're going to end up minimizing some function. So let's write down what we know. We have that x plus y is 8, and we need to minimize x squared plus y squared. Now, the issue here is that this is a function of two variables. And we know how to minimize functions of one variable using critical points. So what we want to do is rewrite one of the variables in terms of the other, and we're going to do this using this restriction here, that x plus y must be 8. So let's say that y is 8 minus x, and then we can rewrite our function as a function of just x. We'll do that up here. So we want to minimize the function. Let's call it, for squares, s of x equals x squared plus, and now y is 8 minus x, so that's squared. Okay, so I'm just going to simplify the form of this function a little bit by expanding those brackets. We get 64 minus 16x plus x squared. And then collecting like terms, we get x squared minus 16x plus 64. Okay, 2x squared rather. Okay, and let's factor out a 2. So we get, actually we'll take the derivative first and then we'll factor, because we want to get the zeros of the derivative. Okay, so remember, to get a minimum or maximum value, in this case minimum, we need to find critical points. Okay, so the derivative is 4x minus 16, and now we'll factor this. This is 4 times x minus 4, and we see there's one critical point, and it is x equals 4 because it makes the derivative of s 0. So because there's one critical point, and we're asked to find a minimum, presumably a minimum exists, and this would have to be it. Let's just confirm that this is indeed a minimum by using the second derivative test. So we take the second derivative, which is going to be 4, and we see that this is always positive, okay, for all x. It's just the constant function 4. Meaning that any critical point, in particular this one, is a minimum because the second derivative is positive. Okay, so x equals 4 is a minimum. And then finally, let's answer the question asked. We were asked what the possible value of the sum of the squares was. So we know what x should be. Then we know y from before is 8 minus x, which is 8 minus 4 is 4. And the minimum value of the sum of the squares is 4 squared plus 4 squared, which is 32. Okay, and that's the solution and answer to question number 14.